Welcome to our lesson today. My name is Purity Anzelimo, and our topic today is trigonometry. Trigonometry. We are going to look at waves. In the previous lesson, we had looked at waves, and we are going to continue with waves. In this lesson, I would like us to be in a position to determine the amplitude and the period without having to draw the graph. So waves, that is again the period. We want also to determine the period once again and also the amplitude. And in this lesson mostly we want to look at the waves, that is finding the period and the amplitude without having to draw the graph. But before we get to that, so that we can make a summary after now plotting the graphs like the ones that we plotted during the next lesson, I would like us to draw the following graph and draw the graph. I want us to do that one, whereby we are going to draw another graph, and we've been given y is equal to 2 sine 2x minus 30 degrees, and we have been given the range, that is from 0 degrees to 360 degrees. And then we are going to use that graph to determine, the amplitude, and the period. So we are going to plot this, then we are going to get to finding the amplitude and the period without drawing the graph. So determine the amplitude and the period after drawing this graph. So again in this we require a table. For this we require the table. We have x here, and then we can go ahead and talk of 2x. We can have here 2x minus 30, or just 2x. We can have 2x, then 2x minus 30, then y. So here we can have the 2x. We get the value of 2x. Then after that we get 2x minus 30 degrees. 2x minus 30 degrees. And finally we have y is equal to 2 sine, now whatever we have gotten here, sine 2x minus 30 degrees. That's our y. So if we have our 0 here, 0 degrees, we have 30 degrees, 16 degrees, we have 90 degrees, we have 120 degrees, 150 degrees, 180 degrees, we have 210 degrees, 240 degrees, 270 degrees, then we have 300 degrees, 300, then again we continue up to 360. Here we have the values of x, here we have 2x, here we have 2x minus 30 degrees, and finally we have y, which is 2 sine 2x minus 30 degrees. So here we have 330 degrees, then we have 360 degrees. Then we move on to 2x. We fill the table so that now we plot the curve, that is the wave for this function. So our 2x, we are going to have 0 times 2, 0 degrees, 16 degrees times 2, 120, 180 degrees, 240 degrees, 300 degrees, 360 degrees, 420 degrees, 480 degrees, we have 540 degrees, 600 degrees, we have 660 degrees, and finally we have 720 degrees. Then we move on to the other part, 2x minus 30. So whatever we have, we subtract 30 minus 30 minus 30. So here we'll have 0 minus 30. That is 2x minus 30. We have negative 30 degrees. We'll have 30 degrees here. Minus 30 here we get 90 degrees. Minus 30, 150 degrees. Minus 30 we get 210. Minus 30 we have 270. 330. We have here minus 30 here. We'll have 390 degrees. Minus 30 again here we have 450 degrees. Then minus 30 here we get 510 degrees. Minus 30 here we get 570 degrees. Minus 30 here we get 630 degrees. Then minus 30 here we get 690 degrees. Then after that, now we get the value of y, which is 2 sine whatever we've gotten here. 2 sine all this, which is here. So we'll have 2 sine negative 30, 2 sine 30. So we have the first one, that is 2 sine negative 30, 2 sine negative 30, which we are going to have as negative 1. Then we have again 2 sine 30 degrees, which is 1. We have 2 sine 90, which is 2. 2 sine 150, we get 1. Then 2 sine 210, we get negative 1. We have 2 sine 270, we get negative 2. 2 sine 330, we get negative 1. 2 sine 390, we have 1. 2 sine 450, we have 2. 2 sine 510, we have 1. 2 sine 570, we get negative 1. Then we have 2 sine 630, we get negative 2. And finally 2 sine 690, we get negative 1. So that's what we have now for our data. Then we can use it now to plot the graph. Draw the graph of this. Then we use it to determine the amplitude and the period. So in this case again, we have the values of x from 0 all the way to 360 degrees. Then we have the highest value here, which is 2. And on the lower side, we have negative 2. So we have it this way. So we are going to have, that's our y-axis. This is our x-axis. We have the highest being 2. So we can have that as 0.51, 1.5 up to 2. 0.51, 1.52. So here we have 1, then we have 2, we have 0, negative 1, and we have negative 2. Then on this side again we have 0 up to 360 degrees. 2, 3, 4, 5, 6, 7, 8, 9, 12, 10, 11, 12, 13. So we have this as 0 to 360 degrees. So we have our 30 degrees, 60 degrees, we have 90 degrees, 120, 150 degrees, 180, 210, 240, 270 degrees, 300 degrees, 330, 360 degrees. Then now we can plot the points, that is x corresponding with y. So we have x0, our y is negative 1, 0, then negative 1 is there, 0, negative 1. Then we have 31. We move on. 30, we have 1. Then we have 62. 60 here, we have 2 at that point. Then we have 90. We go back to 1. 90, we have 1. Then we have 120, negative 1. 120, we have up to here, negative 1. Then we have 150, negative 2. 150, we have negative 2. Then 180, we have negative 1. It's at that point. Then we have 210, we have 1. 210, we have 1, which is at that point. Then 240, we have 2. At that point, we have 2 approximately there. Then 270, we have 1. 270, we have 1. Then 300, we have negative 1. 300, we have negative 1 at that point. Then 330, we have negative 2, which is somewhere here. Then finally 360, we have negative 1. 360, we have negative 1 at that point. Then now we need to plot it. So we are having from 0, our 0 was negative 1. So we are starting from this point here all the way to 30 degrees to 60 up to 360 degrees. So we have it that way. Move on to this point. Then again to 120, 150. Move on all the way to 180, to 210, 240, we have 270, to 300, to 330, and finally to 360. To 360, so we have it this way. It curves at that point up to that point. So that's how our curve will look like. That is our wave. That's the turning point. Therefore it should turn. So then we need to come and write therefore the equation y is equal to 2 sine, we have 2x minus 30 degrees. So that's what we have for y is equal to 2 sine 2x minus 30 degrees. Then we are told from that graph we are supposed to determine the amplitude and also the period. So we can start with the amplitude. The amplitude, which is the maximum displacement from the x-axis. So from this point here, the maximum we have 2. On the other side, the same. So our amplitude will be 2 units. Then we also need to get the period. We need to get the period. And we said when we want to get the period, we consider one complete oscillation. For example, we can consider this oscillation. We can start it from this point here. We move it. This is 60, 90. This is 120. This is supposed to be 150. And then here we have 180. So we can move all the way from here up to when it starts now repeating itself. That is at this point here. So we can read up to this point. So this from here up to here is our period. That is 180 degrees. Again, we can consider this way, starting from this point here up to when one oscillation is complete. It is up to this point. So here we are going to have, this is 180, this will be 195 minus this point here, which is from 0 to half of that, that is 15. That is 0.8, 180 degrees. So for one complete oscillation, you can even get it from here all the way to this point here. This distance is what we are calling, that path is what we are calling the period. And therefore the period here is equal to 180 degrees. So that's how we get the period and the amplitude when we have been given the function, the graph function, and after plotting the wave. And I would like us now to look at how can we get the period and how can we get the amplitude when we do not have this graph. Because we don't have to plot the graph for us to get the period and also the amplitude. So I would like us to look at finding the amplitude just given the function without drawing the graph. And we are going to start by summarizing whatever we have seen after plotting the graphs. So I'd like us to look at how to finding the amplitude and period, finding the amplitude and the period without drawing without having to draw the graph. And in our case here, the graph is the wave, without having to draw the graph or the wave. I would like us to do a summary of what we have covered during the previous lesson and during this lesson. The summary, so that we can get to know how can we now find the amplitude and the period without having to draw the wave. Here we have the function, the graph function, the wave function. The wave function. We have plotted graphs for various waves function. Then we'll have the amplitude, and then the period. In the first one that we drew, the wave function was y is equal to sine x, and the amplitude was 1, the period was 360 degrees. Again we plotted another graph, that is y is equal to 2 sine x, and here the amplitude was 2 and the period was again 360 degrees. Then again we plotted another one whereby y was equal to 2x, to 2 cos 2x. And here our amplitude was 2 and then the period was 180 degrees. We also plotted that. And in this case we have also plotted this curve whereby y is equal to 2 sine 2x minus 30 degrees, and we've gotten that our amplitude is 2 units and then the period is 180 degrees. Now if you look at this wave function here, if you look at the coefficient of the trigonometry ratio, that is, the ratios are the sine, the cosine, and the tangent. If you look at the coefficient here the coefficient is 1. Here the coefficient is 2. Here the coefficient is 2, and here it is 2. So the coefficient of the trigonometric ratio gives us the amplitude. Here the coefficient is 1, coefficient is 2, coefficient is 2, coefficient is 2. So we can say that the coefficient of the trigonometric ratio gives us, or is equal to, that coefficient is equal to the amplitude, The coefficient here is simply what we have as the amplitude. So even if you may have a curve, the wave function, which is y is equal, for example, to a half sine 3x, the coefficient of the trigonometric ratio, our trigonometric ratio is sine, the coefficient is a half, and therefore the amplitude is equal to a half units, is equal to a half units. So that's how we get the amplitude without having to draw the graph. Then I also want us to look at now the period. You can see in this case we have x here, sine x, the period is 360. Sine x, the period is 360. When we have 2x, the period is 180. When we have 2x minus 30, the period is 180 degrees. 180 degrees. Now, I want you to consider the following as I explain how to get the period. Our general equation, the general equation that is for our wave, for the wave, we have it as y is equal to, we can talk of y is equal to a sine bx. It can either be sine, we can also have sine or cos a cos bx. We can also have y is equal to a tan bx, any of the trigonometric ratio. Now if we have our equation as this, that is y is equal to a, let's consider sine bx. Our a here, which is the coefficient of the trigonometric ratio, is the amplitude. This is the amplitude. Then when we want to get the period, we simply take 360 degrees, we divide by the coefficient of x. We divide by the coefficient of x. In our case here, we will have 360 degrees. Coefficient of x is b, and this one will give us the period. You can see from this, our coefficient here is 1, coefficient of x. So 360 divided by 1, 360. 360 divided by 1, 360. 360 we divide by 2, 180 degrees. Now, I want to show you also how to get the period in such a case, whereby we are having y is equal to 2 sine, then we have 2x minus 30 degrees. So this will be 2 sine. We ensure now that this is to the simplest form, whereby we can factor out here the common factor, which is 2 into bracket x minus 15 degrees. So that's what we have. This is our angle, x minus 15 degrees. So we have this, therefore, we can even come and say, let x minus 15 degrees be theta, because that's our angle, and therefore our y will be 2 sine 2 theta. And therefore, from our general formula here, our 2 is the amplitude. This is the amplitude. And then the coefficient of the angle, which is x here, in our case here we have theta, the coefficient here is 2. And therefore, the period will be given by 360 degrees. We divide by the coefficient of the angle, which is 2. So we end up getting 180 degrees. And that's how we get the period. Just to repeat, if we have the general formula for the wave, y is equal to a, it can be sine, cos, or tan, a cos bx. Our a is the amplitude, a is the amplitude, and then when we want to get the period, is equal to 360 degrees divided by b. That is the coefficient of the angle, that is b. So if you have an equation like y is equal to a half sine 2x plus 40 degrees, if you have such, therefore you need to write it in this form, which is a half sine, here we can factor out 2, we remain with x plus 20 degrees. Then we come and say let x plus 20 degrees be theta. So we'll have y is equal to a half sine 2 theta. And therefore, from this, our half is the amplitude, and then our period, therefore, will be 360 degrees. We divide by the coefficient of the angle, which is 2, which is 180 degrees. So that's how we can find the amplitude and the period without having to draw the graph. We can do some more examples on that. We are still in waves, drawing, also finding the amplitude and the period, or finding the amplitude and the period without drawing the graphs. So I'd like us to do the following. Find examples, find the amplitude, and the period, find the amplitude and the period of each of the following, functions. We want to find the period and the amplitude of each of the following functions. So we have the first one, y is equal to cos x. Y is equal to cos x. So we want to find the amplitude and also the period. So we have the general equation, y is equal to mb, sorry, not mb, but a cos or sine. In our case, we have cos bx. So in our case here, our amplitude is the coefficient here, which is 1, and therefore we'll simply come and say that the amplitude is equal to 1 unit. Then our period is 360 degrees. We divide by b. Our b here is 1, so we divide by 1 and get 360 degrees. That's the period. B of that question, we are still finding the amplitude and the period when we have been given the wave function. In our second one, we have y, that is part B. We have y is equal to sine 3 over 5x. That is part B. Y is equal to sine 3 over 5x. Again, come and write the general equation. Y is equal to, we have sine here, so we have a sine bx. And therefore, this is our amplitude. Here we have 1 as the coefficient. So we'll have, therefore, our amplitude will be equal to 1 unit. Then we also need to get the period. Our period will be equal to 360 degrees. We divide by the value of b. Our b here is 3 over 5. So we get 360 degrees divided by 3 over 5, which is 360 degrees multiplied by 5 over 3. So we end up getting by 120 multiplied by 5, we get 600 degrees. That is the period for that wave function. Again, number C, we can do another one. We have y is equal to 2 sine 3x plus 60 degrees. Again, we have that. We have to determine the amplitude and also the period. So in this, again, we need to write it in the form y is equal to a sine bx. So in this we just come and see, therefore we have y is equal to 2 sine. Here we can factor out 3, which is a common factor. We remain with x. 60 divided by 3 we have plus 20 degrees. Then we simply come and say let x, this angle x plus 20 degrees, let it be theta. So we are going to have y is 2 sine theta. Sorry, we have a 3 here. 2 sine 3 theta. And we know that the general equation is y is equal to a sine bx. And therefore our amplitude is this. So the amplitude therefore for this is equal to 2. The amplitude is 2. And then the period is equal to 360 degrees. We divide by b, and the value of b here is 3. So the period will be 120 degrees. And that's how we find the amplitude and the period without having to draw the graph. I would like you to do the following exercise. Do the following exercise. So exercise, there are 2 questions here. We have number 1, find the amplitude and the period. Find the amplitude and the period of each of the following functions. Just like we've been doing. Part A, you have y is equal to 2 sine a half x. Then we have B, y is equal to cos x. And here we have been given the range, that is from 0 degrees all the way to 720 degrees. Then finally, number C, y is equal to 3 sine. Then we have 4x plus 80 degrees. That's what we have for number 1. Then number 2, on the same axis, draw the graphs. And draw the 2 graphs. Draw the graphs of y is equal to cos x, and also y is equal to 2 cos a half x. You draw the 2 graphs on the same axis, then state, after plotting, state the amplitude and period of each graph. So in this you are plotting the 2 on the same axis, and then after plotting, in this case you just state, because it is clear on the graph, you state the amplitude and the period of each of these and of the other. That is after plotting. For this one you are not plotting, you just find the amplitude and the period of each of the following functions using the method that we have already discussed, whereby the general equation, always remember we have y is equal to a cos bx. It can be cos, sine, or tangent, where a is the amplitude and the period is 360 degrees divided by b. So during the next lesson, we shall be looking at some of the transformations, of waves. So we'll be plotting the waves, and then we'll be describing the transformation. Thank you for being a good listener. Let us meet during the next lesson.